Good morning everybody. Last time we had seen the introduction for the electrochemical cell and we had seen different things. The basic introduction we have seen what the electrochemistry is, what is studied in electrochemistry, what the electrochemical cells are, these electrochemical cell in them, how the generation of EMF takes place, that we have seen. For that we have seen the Nernst theory for the single electrode potential. That means the process of de-electronation and electronation, how do they happen. Then we saw the example of electrochemical cell, that is the Daniell cell. The ways in which the electrochemical cells can be set up, that we have seen. We have seen that three ways are there to set up the electrochemical cell. First is by using the porous partition, second is by using the porous pot, and the third is by using the salt bridge. In these three ways of setup of the electrochemical cell, the use of salt bridge in the setup of electrochemical cell is more advantageous. This is because the two electrolytes in such type of the arrangement are not in a direct contact with each other. They are separated in a two different container. The electrical contact between them is given through a salt bridge. We have seen the functions of the salt bridge. Salt bridge, it maintains the electrical neutrality of the electrolytes. Second, it avoids the accumulation of the charges in the partition between the two electrolytes. That means the generation of liquid junction potential is avoided due to the usage of the salt bridges. Now we are going to the different conventions to use the represent a electrochemical cell. These electrochemical cells, these are represented very typically. From left hand side to the right hand side, these cells are written, and there are different conventions used to represent this cell. The first convention is that while writing or representing the electrochemical cell, the electrode with a negative charge, that means the anode which is having a negative charge, it is always written on the left hand side. The electrode on which actually the oxidation is occurring, that we term or we consider it as the anode, and the electrode on which the oxidation is occurring, that is always written on the left hand side, and it is termed as LHE. That means the left hand electrode. It is always termed as LHE. That means the left hand electrode. The left hand electrode, and the second is the electrode on which the reduction reaction is occurring. It is always written on the right hand, and it is termed as RHE. That is right hand electrode. This is anode. Where oxidation reaction occurs. The electrode on which oxidation reaction is occurring. This is a cathode where a reduction reaction is occurring. So this is the first convention, that the electrode on which oxidation is occurring, it is always written on the left hand side, while the electrode on which the reduction reaction occurs, that is written always on the right hand. The electrode on which oxidation is happening, we call it as anode, and that anode is always represented on the left hand, and it is termed as LHE. Short form is LHE, that is left hand electrode, and the cathode where the reduction is occurring, that is always a right hand electrode. So this is the first convention. Now the second convention is that the contact between the electrode and its solution, they are directly contact, right? Because we dip the metal electrode in its salt solution. That means the metal electrode is in a direct contact with the salt solution. So the direct contact in a representation is denoted by a single vertical line. For example, we have seen the example of Daniel cell, where we dip zinc electrode in a zinc sulfate solution or copper electrode in a copper sulfate solution. So they are represented as like this. This single line denotes the electrode and its salt solution are in a direct contact. So to show the direct contact between the metal electrode and its salt solution, a single vertical line is used. The next convention is that the two electrolytes, when they are in an indirect contact, that means when we use the salt bridge, the two solutions are not in a direct contact, right? So in that case, to show the presence of a salt bridge, the double vertical line is used. That means this single line, this what it denotes, there is a direct contact between the copper electrode and its salt solution. Here also, the zinc and zinc sulfate, zinc electrode or a metal rod is in direct contact with zinc sulfate. While this double vertical line, what this shows, these two electrolytes, copper sulfate and zinc sulfate, they are in an indirect contact. That means that they are in a different container. They are taken in a different container and they are connected indirectly by the salt bridge. So indirect contact between the electrolyte is shown with the double vertical line. The next convention is that whenever the left hand electrode where your oxidation is taking place, see here, the reduction reaction, in such cases, while representing the electrode, first the solution is written and then your metal rod is written. On the left hand side, first metal and then its salt solution. Why it is written so? Because here zinc is dissolving in zinc sulfate, while here copper 2 plus is deposited on copper. Hence such representation is there. This is actually the way of representation. The next convention is very important and it is connected to or related to the gas electrodes. In electrochemistry, gas electrodes are also used. But in such cases where the gas electrode is to be used, that gas electrode is incorporated with the inert metal. For example, the hydrogen electrode is to be set up. Therefore, how the hydrogen electrode is set up? We know that hydrogen is in the form of a gas and it cannot be made in a solid. So, how this gas is taken as the electrode? In such cases, inert electrode, inert in the sense which is a non-reactive, that means that doesn't undergo the oxidation or reduction reaction, that is called as the inert metal. Such inert metal like platinum is used, and therefore how the hydrogen electrode is set up? The platinum foil is taken, platinized platinum foil is taken, which is in contact with the aqueous HCl solution, and on this platinum foil, hydrogen gas is bubbled. Now, the platinized platinum foil, that means a platinum foil is electroplated with the fine particles of platinum black. That is called as platinized platinum. Why this is done? Because these fine particles of platinum have good adsorption properties, And therefore, when you bubble the hydrogen gas on this platinum foil, the hydrogen gas get easily adsorbed there and hydrogen gas remain on this platinum foil. So this is how the gas electrode is set up. So in every case of gas electrode, we have to incorporate the inert metal in the representation also. We have to show it in a representation. Chlorine gas electrode also, there also platinum electrode is used, so platinum has to be incorporated in the representation. For example, how it is denoted? See, this is how it denoted is. What does this shows? This shows that the hydrogen gas is bubbled on the platinum, which is an inert electrode. This is not the active metal which is actually oxidizing or reducing. Here this is only used to adsorb the hydrogen gas on it. Actually your electrode is a hydrogen electrode which is in contact, direct contact, single line, that is the direct contact with the aqueous HCl solution. Next convention is that whenever the concentration or the activities of the electrolytes or the pressures of the gases are needed, they are shown in the brackets. That means here the hydrogen gas, for example, it is bubbled at 1 atmosphere, so pressure is included, or here also it can be given. Here also, if the concentration or activities are to be represented, therefore they are represented in the bracket. For example, this zinc sulfate, it is taken to be 0.1 molar. Therefore, in this way such it is shown. Copper sulfate, if it is 0.01 molar, so this is how this is represented. So the activities or concentration, or and in case of the gases, pressures are included in the representation in the brackets. They are represented in the brackets. Now the next convention is that is the direction of the electron flow. Now as we have shown, this is a left hand electrode and this is a right hand electrode. As this is negatively charged, so we have shown negative sign. Here we have shown positive sign. The direction of a flow of electron is from RHP to LHP. This is the direction of flow of electron, and the flow of electric current, the direction of flow of electric current is exactly opposite to the direction of electron flow. This is the direction of flow of the electric current. So this is how the cell is represented. These are the directions represented. This LHE to RHE. This is the direction of flow of electrons by RHE to LHE. This is the direction of flow of electric current. Next convention, that is related with the EMF of the cell, and we have seen the equation. How the EMF of the cell is calculated? The EMF of the cell is equal to, we have seen that, the oxidation potential. Now we can write this as the potential, oxidation potential of RHE plus the reduction potential, this is LHP, and RHP, the reduction potential. This is simple equation to calculate the EMF of the cell. We know that on the left hand electrode oxidation occurs, so that oxidation potential, and on the right hand electrode reduction occurs, therefore the reduction potential, the sum of these two potential is the EMF of the cell. But if we know the oxidation potential of both the left hand electrode as well as the right hand electrode, in this case how the cell EMF is calculated? Both of the oxidation potential, therefore the oxidation potential of LHP minus oxidation potential of Rhe. This is the formula. When for both the cells, for both the electrodes, you know the oxidation potential. This is the equation. That means here the reduction potential as it is positive, but its oxidation potential will be negative, hence the sign negative. One more formula. If you know the reduction potential of both, if we know the reduction potential of both of the electrode, therefore EMF. Now here that of the Rhe minus reduction potential of LHE. This is the formula. That means that the electrodes on which the oxidation reaction is occurring spontaneously, those electrodes are having same reduction potential but opposite in the sign. That means that for a particular electrode, its oxidation potential, if it is positive, therefore its reduction potential will be, the value will be exactly same, but it will be negative. For example, zinc electrode. Zinc, if in a zinc sulfate, actually this metal is having more solution pressure. That means it is having a tendency to dissolve in the solution in the form of a zinc 2 plus ion, leaving the electron behind. So its oxidation potential will be the certain value and it will be positive because it is having more solution pressure. But if we want to consider its reduction potential, the value will be exactly same, but only the sign will be negative. That means the oxidation potential for particular electrode is the same, but with a negative sign, its reduction potential, and the metal for which its reduction potential is positive, ज्या मेटल साठी त्याचा ऑस्मोटिक प्रेशर जास्त आहे, म्हणजे ज्यांची टेंडन्सी, ज्या आयनची टेंडन्सी इलेक्ट्रॉन ऍक्सेप्ट करून इलेक्ट्रोड वर डिपॉझिट होण्याची ज्यांची टेंडन्सी जास्त आहे, ऑब्वियसली दे विल अंडरगो रिडक्शन रिएक्शन स्पॉन्टेनियसली, म्हणजे ते रिडक्शन रिएक्शन होईल. पण त्यांचं जर ऑक्सिडेशन पोटेन्शियल रिप्रेझेंट करायचं असेल तर त्यांचं रिडक्शन पोटेन्शियल हे पॉझिटिव्ह असतं, मग त्यांचं ऑक्सिडेशन पोटेन्शियल हे ऑलवेज निगेटिव्ह असेल. अँड दॅट्स व्हाय दिस इक्वेशन्स आर गिव्हन. सी या इक्वेशन मध्ये आपण काय केलंय, ईएमएफ ऑफ द सेल इज, आता लेफ्ट हँड इलेक्ट्रोडवर ऑक्सिडेशनच होतं स्पॉन्टेनियसली, म्हणजे ते जे काही त्याचं ईएमएफ जे असेल ते पॉझिटिव्हच असणार. पण हा जो राईट हँड इलेक्ट्रोड आहे की ज्याच्यासाठी त्याचं रिडक्शन पोटेन्शियल पॉझिटिव्ह आहे, त्याचं ऑक्सिडेशन पोटेन्शियल ते निगेटिव्ह असणार, म्हणून इथे आरएचची जर इथे निगेटिव्ह साइन आलं जर ऑक्सिडेशन पोटेन्शियल रिप्रेझेंट करायचं असेल. त्याचप्रमाणे इथे हिअर ऑल्सो the reduction potential of right hand electrode is positive, so positive we have taken first, and left hand electrode on whose oxidation occurs, therefore its reduction potential will be negative, else minus reduction potential of left hand electrode. So these are the conventions which are used to represent the cell. Now we are going to see some examples. So first example we are going to take, we will take the example of the dimer cell first. How to represent that cell? We know the cell reaction. In this ways, we are always given the cell reactions. This is the reaction we have given, and we have asked to represent the cell. So this is the net cell reaction for the cell we have given. And now we have asked to represent the cell. So how to represent the cell? For representing the cell, first write the different half cell reaction. That means at anode, what the reaction takes place, that we are going to see. Or we call this as half cell 1. The reaction that takes place will be zinc will gives rise to zinc 2 plus 2 electrons. This is the oxidation reaction that is occurring at anode, or we can write this as at LHE. So this is the reaction at LHE. At RHE, or at the cathode, that is the half cell 2, the reaction that is occurring is, obviously here copper is in a 2 plus oxidation state, right? So copper 2 plus this SO4 2 minus plus 2 electrons. The 2 electrons, and this copper will take these 2 electrons and will form the elemental copper plus SO4 2 minus as it is. Therefore, next cell reaction. What the next cell reaction will be? Zinc giving rise to zinc 2 plus 2 electrons and copper 2 plus sulfate ion plus 2 electron gives rise to copper plus SO4 2 minus ion. Right? Here we left to write reduction. So our next cell reaction is zinc plus copper 2 plus SO4 2 minus plus 2 electrons is equal to zinc 2 plus 2 electrons plus copper plus SO4 2 minus ion. So if you cancel this same, or you can write this as zinc sulfate also. Instead of cutting them, you can write it as zinc sulfate also. And here you can write this as copper sulfate. That means your reaction becomes, if you cut only 2 electrons, therefore what it becomes, zinc plus copper sulfate is equal to copper plus zinc sulfate. Zinc will form the zinc sulfate with the SO4 2 minus ion. So this is the next cell reaction. Now we are going to represent the cell. See therefore how the representation will be. First represent LHE. First represent left hand electrode. On the left side, here this zinc is in the contact with zinc 2 plus, that means which solution? You can write this as zinc sulfate or zinc 2 plus also. You can represent this like this, or you can write just zinc 2 plus. Now they are in a same contact. Now here they are the two electrolyte, whether they are in direct contact or direct, it is not sure. But let's consider that they are in a direct contact. So this is the representation of LHE. Now how to represent RHE? While representing the RHE, first write down the aqueous form of your metal ion. That means either you can write this as copper sulfate or only copper 2 plus. This is in a aqueous form which is in contact with the copper. So this is how the cell is represented. Here the sign is negative because this is your anode, this is your cathode, this is the flow of direction of the electrons, and this is the flow direction of flow of current. So this is how the cell is represented. Instead of writing their sulfates, you can write this as this also. You can represent it such also. Need not to be write their solution. You can write them as in a 2 plus form or in a ionic form also. This actually means they are in an aqueous form. So this is how the seal is represented. If these two solutions are in an indirect contact, therefore double line has to be given. Now let's take the example. See, we have given the reaction twice of silver plus twice of Cl minus plus copper 2 plus gives rise to twice of silver chloride plus copper. So this is what is the reaction we have given, and we have asked to represent the cell. So let's first write the reaction at RHE, the reaction at LHE first, then RHE, then net cell reaction, and then we will represent the cell. First at LHE. Now at LHE, that means the left hand electrode, what will happen? At the left hand electrode, obviously oxidation reaction is going to happen. Oxidation, or we can call it as de-electronation also. So find first which metal has undergone the oxidation reaction here. So which metal here is oxidized? See here Ag plus and Cl minus, that means Ag plus is formed. Primarily it is in the form of silver. It got oxidized to Ag plus. So this is the reaction taking place at we have to find where exactly the oxidation is occurring, and then we can write it at the left hand electrode. So this is a de-electronation or oxidation. You can write it here oxidation also. So this is a de-electronation at RHE. At RHE, copper 2 plus is getting converted to copper. Actually 2 need not to be incorporated, but to reduce copper 2 plus to copper we need 2 electrons. One silver is getting only 1 electron by forming Ag plus. Therefore 2 atoms of silver has to be oxidized. Therefore 2 electrons we will get. Therefore copper 2 plus 2 electron will give rise to copper, and this is electronation, or you can write this as a reduction. Now net cell reaction. Now here 2Cl minus are given. The oxidation state of a chloride here is 1 minus, and here how much it is? Again 1 minus. That means here chlorine is neither undergoing oxidation or reduction reaction here. Our main metals that are undergoing oxidation and reduction are silver and copper. This is not oxidizing or reducing. Therefore net cell reaction is twice of silver. Just add up these things which are on the left hand side of the arrow. Therefore left hand sides are twice of silver plus copper 2 plus 2 electron, which gives rise to, which is equal to twice of Ag plus twice of electron plus copper. 2 electron get cancelled. Similar terms on the both sides we have cancelled. Therefore our final reaction is twice of silver plus copper 2 plus is equal to twice of Ag plus copper. So this is our net cell reaction. Now we are going to represent the cell. See, therefore Now the silver, as it is forming AgCl, that means this is in contact with chloride ion containing solution. Here the solution is of the silver chloride. Actually here silver chloride precipitate must be present here. That means you can write this as this solid must be present and also Cl minus ions are there. If these two are in an indirect contact, therefore copper 2 plus with copper, or this rather may be written as this is how this cell is represented. What does this mean? This is in a direct contact with a silver chloride precipitate and also the solution containing Cl minus ion, and in that same solution copper electrode is dipped. The copper electrode is dipped here, and this is how the representation is. Why I have shown single line? This means that these two solution or these two electrode, this solution is in a contact with this electrode as well as this electrode. Hence the single line is there. So this is how the cell are represented. Let's take one more example. A simple example we will take. Plus cadmium in a solid form plus Ag2SO4 giving rise to, or it gives to cadmium sulfate plus twice of Hg. Now this is how the reaction is given. Now how this is to be done. See, this is also in the form of a precipitate, mercurous sulfate. Now how to represent this cell? Let's first write at LHE. At LHE, obviously this is getting converted to cadmium is getting converted to here. How much is the oxidation state? 2 plus. This is getting oxidized. Cadmium gives rise to cadmium 2 plus plus 2 electrons. This is oxidation, or you can write here as de-electronation. And RHE, here Hg, how much is the oxidation state? SO4 is 2 minus, so 2 Hg ions are having 2 plus oxidation, that means 1 will have 1 plus. Plus, so 2 ions with the 2 electrons will get converted to twice of Hg. So this is a reduction reaction. So next step reaction is cadmium plus twice of Hg plus. Now this 2 electron on the both side if I cancel, therefore is equal to cadmium 2 plus plus twice of Hg. This is your net cell reaction. Therefore, how will you represent this? Here also mercurous sulfate is in a solid. Therefore, the left hand electrode This is how the representation of cell is. This is a solid. So both of these electrodes are in a contact with the aqueous solution containing sulfate ion, and hence a single line I have shown. A single line is there. Rest of the examples we will see next time, or we will send them as the assignments.